Hello and welcome to our fourth week of class for our wonderful science students. This class is made up of 25 honors students who absolutely rock. They've been doing so well navigating all of the new Google Classroom things that we're going through, and they're really keeping up with all of our expectations. They're absolutely awesome. So today's focus is going to be what is weight, and also how similar or different is it from math. What we'll use is Google Classroom. The Classroom has a chat box option on the side, so we ask that all the students keep on their cameras and mute their microphones when they're not using them and unmute when we ask them questions, but some of them have some difficulties with that, just between maybe the type of computer they have or their resources. So the chat box is always an option, and it's usually good for quick responses if they need to write something out, but with their cameras on, we can have them do a thumbs up or thumbs down to also quickly respond as we're going and gauge what we should review and go back over. They also learned how to do a new Google Slide program on Friday. This class that we're watching is a Monday. So we went through that and we set up our very first one. So they should be able to navigate back to that. I set it up so all of their slides are in one long PowerPoint so they can review that as the semester goes on. So let's review. On Friday, we started Unit 1, which is gravity. We started by taking a pretest. I set it up as what do they know going into this unit. I reminded them it wasn't graded, to just go through it, look them over, see if they did know something, if they did answer it to the best of their abilities, and come back to class. So they went through, they did really well on answering all the questions and navigating back to the classroom, and I'm using those questions asked that they struggled with to sort of replan and go back through and make sure we review those well throughout this unit, so then by the end of the unit they know every question from that pretest. We also watched an introductory video. So this video, while they watched, I asked them to try and define mass, weight, and gravity. In the video, mass and gravity were very easy to pick out. It almost, for gravity, it did write it on the screen, and for mass, it said it twice, whereas weight, it said it briefly. So I do anticipate that of all the three defined terms, this one will be the one that they maybe struggle with and didn't pick up as well. So we'll have to go over that one just a little bit more in today's lesson. We also, as I said, created our first vocab slide, and it was on mass. So they have their expectations that there are 5 parts of every slide, and we'll go through and fill them all out, and at the end they turn in all of their slides and they're graded. So they should know what each area expects, as we did go over those, but I will review them again today and each coming day just so they know when they review their slides. Again, that's the next one, reviewed expectations of slides. So there's 20 points total, 4 slides, each having 5 parts. In the middle of the slide is their term. They fill in what they have defined it as, an example they can think of, a picture, and also what unit goes along with that. So then we moved on to answering questions on math. So I had pre-planned questions, and they went through, and by the end of the lesson, the kids all had thumbs up. They were feeling pretty confident on how they should define and think of math. Today we're going to go over our slide on math briefly, just to make sure that there weren't any questions, that if people didn't finish in class, they knew what they needed to go home and do before we move on to the next slide. We will go over our examples of math again. So the kids came up with really great ones. I used the example of an apple because we could take a big bite and then its matter changed in what we were holding in our hand. And then the definition of mass, because we want them to really know the definition of mass before we learn weight, because weight and mass can be very similar and very confusing, but we want to know a clear distinction. What we will accomplish today, we're going to define weight. Again, the video didn't do the best job of breaking it out clearly, so I'll probably help them and guide them a little bit more than I did with math. On math, they wrote out the answer and they were very quick about it. Creating our slide on weight, so I'll give them time to create that and ask them about what they were doing, what they found, and then show them my example that I created so they know what the expectation is. Group feedback on understanding. So for this, I want them to go through and thumbs up, thumbs down as we're going on each section of that. comparing the terms, so we will go into comparing weight and mass, and I want them to have a clear distinction between the two, that on Earth they seem to be interchangeable, but if we were to go somewhere else outside of the Earth's atmosphere and the Earth's gravity, then those terms would be more important to know the difference. Then questions from me. So I'll show you on a later slide the questions that I'm going to get through in this lesson, and then questions from them. If they have any, I want them to be asking questions as they go along in the chat box, which I'll have open, and also if they would like to unmute and be part of that discussion. So additional resources, I created a slide with a scale and photos to show it's a spring scale to measure newtons, so I'm hoping that brings in a unit for them to review and go over, as well as showing that force is pulling down on that scale, so gravity is important to weight. We'll also go over the slide I created. So the slide is going to be the term in the middle with my definition and all of that, so they can see my clear expectations, but I'm going to give them time to create that first before I show them. And that's kind of going to be my almost enrichment between this class and a later regular class, whereas the regular class, I may show them the slide as they're creating it so then they can go back and reference it, whereas for this honors course, I want them to attempt it on their own without that support at first, and then give them the support later to compare and contrast between what they had done. The questions I'll ask will be near the end of the lesson, and it's can your mass and weight be different? So they're going to have to bring in gravity at some point. That's going to be a key term there. They're going to need to know that maybe if they go to a different place, then yes, they will, or no, they will not. If you go to the moon, does your mass or weight change, and why? So I want them to go over that, talk amongst, figure it out for themselves, and then unmute and write in the chat. Give them some time for that. Why does a metal anchor sink, but a metal boat floats? I want them to review that. So it's the same type of material. Why would there be a difference there? And then last, if you wanted to change the mass, what would you do? And if you wanted to change weight, what would you do? So just reviewing that, we went over the changes to mass last week in very good detail, and they were really good at coming up with examples. So I'm hoping that that will be a slight review, as well as pulling in this new term to review just a little bit more. All right, everybody, welcome back today. So everybody take a second and write something that you did this weekend in the chat. Let's go with that. Simon, did you do anything cool this weekend? No. Oh, slept for another 3 hours. Nice. Good perk. Hope it was an additional 3 hours, not only 3 hours. Went to Indiana, went to a hockey game. Nice. Friend's birthday. Oh, that's a good weekend. Oh, Leah. Leah, you went to dinner. Going back to last week Friday, did you increase your mass? Is there more matter to you after that dinner? Yes. Sounds good. So we're going to open our slides and go back to what we were rocking the other day, our awesome mass slide. Watch the White Sox. Nice. Perfect. So to review, let's go over our examples of mass. So go back to your slide of mass and find what you wrote your example to be. Now I want you to come back to this chat and write 1, what your example was, and 2, a way to increase or decrease your example, and write if it's an increase or a decrease. So if my example was an apple, none of you should have used my example. I would write an apple. To decrease it, I would take a big bite of it. Good job, Caleb. Notebook, tear out pages, add post-its. Nice, Jema. Way to do both. Orange, take off its peel. Pencil. Nice. Perfect. You guys had really great examples. And if you want to add these under your example to write in the way that you could increase or decrease its mass, that will only help you because you can use these slides on your quiz, so it can be an easy reference for you if you want to go back and add those. If you have any questions on how to increase or decrease its mass, you can definitely go over that. But you guys came up with some good examples. Let's see here. Jessica, what did you come up with? What was your example?
A phone.
A phone, and then how could you increase it?
By adding a case.
And then could you decrease it at all?
By taking out some of the components in it.
Nice. Yes, that'd be a really great example. Ella, did you have one?
Yes, I did.
What was your example of mass?
Mine was a tennis ball, and to increase it would be to add more tennis balls, and then to decrease it, you could cut it in half.
Yeah, so could we put more air into it? Would that increase it or decrease it?
Would increase it.
Perfect. All right, so today we are going to move over to weight. So weight is sometimes confused with mass, so we want to make a very clear distinction and know that we know mass first. So when we move into weight, we will not confuse the two of them. So did anybody take notes from the video and figure out what the definition for weight might be? Caleb.
How much gravity pulls on an object.
Awesome, perfect, yes. That was a good example. So when we think about weight, we need to think about gravity. And when we think about mass, we need to think about matter. So those are the key terms that link there. So I'm going to bring up my page here, and I'm going to show you an example that I think is pretty great. Tell me when you can see my screen. Alright, so this is an example of a spring scale. If we were here in person, we would definitely be using these in class. So this spring scale, you put a weight at the bottom of it and it pulls it down. So this one measures newtons. So as it pulls down, we can find out how many newtons it is measuring. So here's our weight. And then we need this hook here because it attaches onto the spring scale. So they put on a few of these. And then they put it on the bottom hook. And as you can see, it pulls down. And that's measuring its pull in newtons. So these weights all together are 1 newton of force pulling down against gravity. All right. So when you think of this, you can think of the Newton scale or maybe a grocery scale pulling down. But gravity is going to be very important to your definition here. So I'm going to give you couple minutes, about 3 minutes, to go through and let's fill out your slides. So we should have already filled out this first one. The very first one should say mass in the middle with our definition, our example, our unit, and our picture. And then when we move to slide 2, it has a W, and this one we fill in weight right here, what our definition is. So you can write the definition you think of, and afterwards I'll give you what I wrote mine as, but make sure your definition includes gravity in it and an example you can think of. And if you want to fill in picture now, you can, or we can go back and fill in picture later, but take a couple minutes to start filling this out, okay? All right, so I'm going to give you another 30 seconds to get some of those thoughts down. And as you head back to this link from your slide, then let's go and think about how is weight different than mass. And you can write what you think the important term there is in the chat box. How is weight different from mass? So Niraj, is mass always the same? We can't increase it or decrease it?
I mean, like, it depends on the gravity, so you
Perfect.
can decrease it, increase it.
So if we had this pen and we went to the moon, would its weight or its mass change?
The weight.
Perfect. And then in that situation, would its mass stay the same or change?
Stay the same.
Perfect. Good job. So good. Yes. So we said in all of these that gravity is the important difference between mass and weight. So let me go over my slide here. Yes, thank you all for writing. That was awesome. Can you all see my screen? Perfect. Oh, it's loading. Thank you, Leah. Okay, so let's go over. So a spring scale needs that pull. What is that pull? What did we just go over? Write it in the chat. What's that pull called? That pulls down a spring scale. Awesome, Lucy. Awesome, Niraj. Yes, Jessica, Olivia, Shadima. Nice. So yes, weight is measured in newtons on a Newton spring scale. Using the spring scale, we can see the force pull the spring downward. So this one up here, it says it can handle 20 newtons and our mass is 10 newtons. So if we put it on here, it pulls it halfway down. And then at the point that we can see it, we realize that it is a 10 Newton weight. So up here, this was my example. I put weight in the middle. I made it nice and easy to see. And then my definition was weight measures the force of gravity pulling on an object. So the terms that I think are important here are gravity is going to be the most important. Gravity is a force, and that it is pulling on whatever we are using, so our object. I thought of an elephant because when I think of something with a lot of gravity pulling on it, I think of a bigger creature, like an elephant. So I wrote that he is 20,000 newtons, and then I wrote newtons as my weight up here. So looking through this, let's go back to you guys. And let's see here. So do you want to write what your, in the chat box, write what object or example you used for weight was, and then write a way that you can change the weight of your object if gravity is important. Awesome, Caleb. So Leah, with yours taking the keys off, that's a great example because there's less gravitational pull on it in that case, but that one might be better for a mass, whereas gravity we want to think of, or for weight we want to think of gravity. So yes, everybody's saying to go to a different planet, going somewhere else than Earth, somewhere else than the solar system. Perfect. But this can be really confusing because we measure ourself in weight and we talk about how our weight changes. So why do we measure ourselves in weight then? Brayden, why do we measure ourselves in weight?
Because we're different in space.
Awesome. Yes. So what was our definition of weight? What did you write?
Weight that measures the force of gravity.
Perfect. So how often do we leave this gravitational pull?
Never.
Yeah. So is that a good reason why we might measure ourselves in weight?
Mm.
So when would we measure ourselves in mass? Yeah, Olivia.
You want to be an astronaut?
Perfect. So if we lived on a different planet, would it matter a little bit more mass and weight? Or if we traveled between them? Yeah, Angelo, why would it matter?
Can you repeat the question, please?
So if we were traveling between planets, would it matter a little bit more if we measure ourselves in weight or mass?
It would matter if we measure ourselves in mass more because, there's no gravity pulling down on us, so weight wouldn't matter at all.
Wouldn't matter. Okay. So our mass would stay consistent. Is that what you're saying? Perfect. That's a good example. Thank you. And Leah, you put a question mark at the end. Why did you put a question mark at the end of your statement?
I was guessing because I wasn't sure.
All right. So then what was your example for mass today?
Piano.
A piano. Okay. So then if we wanted to change the mass, so the amount of matter, how could we increase the mass of a piano?
Like put a person on it or something.
Perfect. And how could we decrease its mass, the amount of matter?
Take off the keys.
Awesome. So then what was your definition of weight?
What?
What was your definition of weight, Leah?
I said weight is shown by how heavy the gravitational pull is.
Perfect. So then how did we change the weight of our piano?
By putting it in space.
Awesome. Good job. Good job coming around to that. All right, perfect. So does anybody have a question on the slides that we created today? Is there any part of the one that we did yesterday or today that's confusing or we don't have filled in? If we have those pieces filled in, then we have 10 points towards this total. And again, we will use these on our quiz. So then when we get to that quiz, then the more you have filled in here, the more you are rocking on that quiz. So let's go over how can your weight and mass be different? How? How about you, Caroline? How can your weight and mass be different?
I think that your weight and mass could be different because, say maybe that you drank a lot of water, you would have more mass, but maybe you wouldn't gain as much weight as how much mass that you would gain.
So let's go through our definitions again. I like that you had mass in there, so that went with which? That we have more matter or more gravitational pull?
I think you would have more matter.
Perfect. So then if we wanted to change our weight, what could we do?
Go in space or go in space.
Awesome.
On the moon or something.
Awesome. And how about Sneha? What about you? What's a good example of how you could change your weight and mass?
Changing your weight and mass, you can like the other people said, you can like go to a different planet.
And what would that change?
Huh?
Which one would that change?
That would change the amount of gravitational pull. You know what I mean? You like less heavy and like it would like make you lose weight and stuff. So.
And what would change your mass?
Change your mass when like if so the mass's definition was the amount of matter in an object. So I guess like if you lose your weight, you can also lose mass, I guess.
Yeah, so if you were to eat a bunch, then your matter would change, right? Perfect. Good job. That was a good one. Okay, so then we can write in the chat, if we go to the moon, what's changing, our mass or our weight? Awesome. You guys wrote that so quickly. Weight. Weight's dependent on gravity. If we go to the moon, our gravity changes, pulling down on us. Awesome. Awesome. Right. Okay, so let's review this. This one's going to be a trickier question for you all. I want you to think about it for a minute. If you have a metal anchor and a metal boat, why does the metal anchor sink while a metal boat floats? Let's see here. Caleb, do you have an idea?
The anchor has more mass, so gravity affects it more and it pulls it down. And then the boat has air in it, which makes it float in the water.
So if they have the same mass, how does that change your example?
Well, the boat is more buoyant, that's the word, which makes it float and the anchor sinks because it's just a solid piece of metal.
Good job, yeah. So you're going with volume there. That was a good example. How about you, Adriana?
Is it because the boat is like more evenly distributed with with its weight, and the anchor has more mass in one spot,
Do you know what that's
which
called?
makes it sink?
So surface area?
Yeah.
Perfect. Good one. Olivia, how about you?
I was gonna say that kind of similar to what Adriana said, where there's a little bit of there's a lot of mass distributed evenly, and there's also some air, like different air capsules at the bottom of the boat to make it float rather than have it be filled all the way through with mass.
Yes, Roisin. That was a good. Oh, yes. Thank you, Olivia. And Roisin, what did you write? That was a good one.
A boat is hollow, unlike the anchor, so the anchor is more likely to sink.
Yes. So if all of that mass is in one area, then it's going to, because if we had a boat and an anchor both in the air and we dropped them, gravity would pull on both of them would fall. But one has more mass in a certain area, so it's going to pull on it, right? Good. Oh, good. I'm glad you guys were thinking the same thing as one another. Awesome. So then let's review again. If we want to change mass, write your example, mass. Changing it, what could we do? Hayden, what could we do?
I'm not really sure.
Do you have your
To change
slide?
the mass,
Yeah, what was your slide from Friday?
my example.
Yes.
My example was a volleyball.
Perfect. How could we increase the amount of matter inside that volleyball?
If it's deflated, then you could put more air into it.
Awesome. And how could we decrease it?
Take out, deflate it.
Perfect, perfect. So that was a good example. You're changing the amount of matter. Now if we want to change weight, what was your definition of weight?
My definition was the force of gravity when it pulls to an object.
So if we want to change its weight, and weight is the force of gravity, what would we do?
If it's an object that you can't, for example, if it's an animal and you can't, have it exercise to, lose weight on the animal, then you can take it to a different planet where there's less, less or more gravity, a unique kind of gravity, instead of just having it on Earth.
Awesome. So if our volleyball was on Jupiter, would its mass or its weight change?
The weight,
Perfect, yeah. So why would its weight change?
because the gravity, in space, there's not much gravity, so the gravity isn't pulling it to the Earth to make it weigh more.
And why would its mass stay the same?
Because the mass is what's inside the object, and what's inside the object is still staying the same. Well, for the volleyball, the mass would be inside the object.
Good job. How about you, Brandon? Did you have an example for mass the other day?
Can you repeat that?
Did you have an example on your slide the other day for mass?
Yes.
What was it?
I did elephant.
Okay, good, yes. So then how could we increase the mass of our elephant?
We can eat more.
Perfect. And how could we decrease it?
We can decrease it by taking off a husk or.
Yes, those are really good examples. Awesome. And then if we used our same elephant for our example of weight, how could we change the weight of our elephant? Do you have your definition?
Go to a different planet.
Perfect. Yes, our elephant probably would not be too happy with us, but a different planet. Exactly. Thank you, Brandon. That was good. And Dominic, what was your example of mass?
My example was a quarter on the moon and then on Earth.
So then, when would it change its mass?
Because there would be less gravity on the moon pulling on the quarter, making it weigh less.
Perfect. What about mass, though?
Wait.
So you have
it would have the same mass on Earth and on the moon.
Awesome. Good job. Perfect, perfect. Nindago? What did you say? You wrote in the chat, I think. You wrote something good.
We're changing mass?
Yeah, so what was your example for mass today? Or yesterday, Friday?
For yesterday, my example was a watermelon, and to change the mass, you could like cut part of it off.
Perfect. And then if we were to update that to weight today, how can we change its weight?
Not sure.
What was our definition for weight? What did you write on your slide today?
Weight is depending on gravity, so if there's no gravity, we can do it.
Cool. So what would we do to our watermelon if we want to change gravity on it?
Take it off Earth or something.
Awesome. Yes. Good job. That was a good example. Did you have a different example for weight today than your watermelon?
If I had a bowling ball.
Nice. That's a good one too. Yes. Good differences. Good way to think between them. All right. So then let's see here. Oh, welcome back, Angela. Good job. Come back. Perfect. So does anybody have questions going over their slides today? Did we get all 5 pieces? Awesome. So let's see here. If we go over this one more time, I want you to see the example of the spring scale just one more time. Can you see it? Tell me when you can see it. That's okay, Angela. Don't worry. Awesome. So then just one more time looking at the spring scale example. This is a really great way if you want to even include a spring scale in your example under what you've thought of today. This is awesome because it does say newtons right on it. It's a good way to remember our unit that we're reviewing. We have the masses, the different weights, so as we increase and decrease weights, then the amount of gravity pulling on it will change. So if we only put one of those on there, then this Newton scale would probably move a little bit less, and if we put more on there, it would move more. And we can see that that's gravity working on it. So we put it on the end, and we directly see this. So this is a Newton scale. We might also see this in the grocery store when we measure our groceries. So it pulls down with that force of gravity. So you can remember that pull is a force, and that force is gravity pulling down and measuring a weight. Good job. So, were there any questions on weight today? Yeah, Adriana.
What do we use newtons for in the real world?
That's a good question. So newtons are great for smaller things like those weights. So that's based on Sir Isaac Newton because he found out this theory, right? So if we were to think of a different unit for weight, Adriana, what could we think of?
Different unit for weight would be like pounds, like stuff like that.
Perfect. So then when we thought of mass the other day, I wrote the example of grams. That's the metric example. So yes, we can also use pounds. It's a good one. Thank you for asking that question. It's a good question. All right, so then let's see here. How will we? So which term is more closely related to gravity? As we move forward, gravity will be our next term that we go over. So which term, mass or weight, is more closely related? Good job, Olivia. Yeah, Niraj, Leah. Good job. So if you have that, write it in the chat now. We're going to go over that. Which one's more closely related to gravity, weight or mass? Awesome. Let's get everybody written in there. Perfect. So that is definitely what we'll need to use. We'll go into the term gravity. We'll need to know, yes, measure force, not just gravity. Good job. We will need to know that weight is dependent on gravity. So we will go over gravity next when we come back. We'll need our slides. So if you didn't finish those today, that's your only homework. And we will rock when we come back to class on gravity. So good job. If you have any questions, you can write them down, but otherwise we'll see you.